So, NVIDIA is at the center stage of the artificial intelligence, and we have partnered with a lot of firms, big firms, who produce a very, very important software tool, which is popularly known as frameworks. It is these frameworks on which all the models and the data reside, and these frameworks play an extremely important role in ensuring that the algorithms that you write for your AI needs are written properly. And of course, I mean, who else other than Microsoft can be one of our important partners in this area? And I'm very happy to introduce Dr. Sayan Pathak, who is the principal engineer and machine learning scientist at Microsoft. And he is currently working on a very, very important tool, which is really gaining a lot of attention in the AI world, called as the Microsoft CNTK. I'm sure many of you would have heard about it. And his area of interest particularly is on speech recognition, which is about to achieve, or it has surpassed human parity in terms of conversational speech recognition. So, Dr. Pathak, can we have? Yeah.
Talks in such a nice context that of the talking that I'm going to do has already been done. But that doesn't mean that you are going to get a lot of redundant information. Maybe I'll get some time to go in a different tangent. But one thing I want to let you know that I'm going to start at a very high level and then slowly descend from this 50,000 feet level down to the ground. And if you want to have the bumpy road ride, we can also do that if we have enough time. All right. So, in the spirit of democratizing AI, which has been our goal, our CEO Satya's mission, we have it open sourced that is production grade and is meant for deep learning. Can I get a quick show of hands? How many of you are practicing deep learning? And how many of you are using toolkits other than CNTK or Cognitive Toolkit? Great. Hopefully, you see where this toolkit fits in the whole ecosystem of all the open source options that you have. And you will get a chance to taste it also, should you put a little bit of effort behind it. All right. I think it's one slide. So, Microsoft Cognitive Toolkit, formerly known as CNTK, is a fully open source deep learning toolkit. It's focused on ease of use. That means what problems you want to solve, you want to get into that. And it doesn't focus on how. But if you want to get to the how, obviously you have the source code with you. You can go deeper. And if you're interested in getting to build new things, I strongly recommend that you go into the how part of things. It's very fast, and hopefully by the end of this talk, you'll be convinced that its edge on the performance is one of its key discriminators. And with the new releases that are coming out, we are focused on flexibility as well. So it's supported on both Linux and Windows platform, and it has a fully open development framework, which means that there is no internal code base. So everything is on GitHub. All the branches are on GitHub. So you can do your fork yourself on the GitHub and see what's going on in that ecosystem of open source software. I do get these questions, are you from Microsoft? I say, yes, I'm from the new Microsoft, yes. I've been with Microsoft for a long time, and it's a really exciting moment to be part of that journey. Many of these things that appear on this list you have already seen in either Steve's talk or the previous talk. All right. Quickly go through some of the applications that you may or may not have heard as much. Microsoft Cognitive Services, how many of you have heard about that? So this is a framework, for those of you who haven't, which enables bringing AI applications to your doorstep where you don't have to worry about how to scale them. You can actually build, the services are provided to you. There are a lot of applications. I'm going to showcase a few of these for you to get an idea, but these are powered by Cognitive Toolkit or CNTK. Skype Translator, we talked about language translation. That's a rich bed for deep learning, and it uses the Cognitive Toolkit. Our previous speaker alluded to Cortana, so I won't go deeper into it, but suffice to say, with our expertise in speech recognition, state-of-the-art technologies are available and which is available in that released code base, by the way. So if you want to try it out, you can surely build it out of the box. Bing and Bing Ads both use the cognitive toolkit. Bing uses it for relevance, and Ads uses it for a variety of matching of query to keywords, and also recognizing objects in images, and then matching up it against the advertiser-provided assets. HoloLens. I'm not sure if you guys have seen the demo that was done couple of months back, where within the virtual environment, you were able to identify different objects. And this was in partnership with a company called Lowe's, which is a big provider of various home improvement and provide a variety of kitchen equipments and beddings, plumbing, electrical, what you have. The idea is that when we all have homes and we remodel, we do paints, and we do cupboards, but a big time goes in selecting these things. A VR-based environment is ideal for that, where you can actually render your environment the way you want, and then you provide the color schemas that you have. This toolkit actually enables the matching of a variety of products that Lowe's has within that schema of things, within the schema, your personalized schema. So there are a lot of applications like that are popping up, and Microsoft Research provides a lot of firepower behind many of these very advanced toolkits, very advanced use cases that is provisioned by this toolkit. So a lot of people have talked about computer vision, so I won't beleaguer you with more information, but just to kind of set the framework, most of the folks that were talking before, the tasks fall under these categories. Classification, the first one. Classification and localization, where you are putting a bounding box. You saw some nice examples in the previous talks. Then you have multiple objects detection. And then the next one, which is instance segmentation. So if you are going to spend a lot of time doing medical imaging and doing segmentation of various organs inside human body, including pathologies and normal organs for a variety of use cases, and segmentation is a big challenge. Deep learning is going to revolutionize all of that, and you need a lot of computing power to make that possible. We talked about ImageNet, so I would assume you would know that. It's one of those data sets that allows you to nicely benchmark your algorithms against existing algorithms, but needless to say, in year 2012, AlexNet really revolutionized the field, as previous speakers have said, and you can see that, like VGG, AlexNet had about 12 layers, VGG about 18, 19 layers, and ResNet, which was our solution to the challenge, was 152 layers. When you are getting to that level of depth, you need some very intelligent way of computing the gradients, which is made available to you. But more importantly, you have to be able to write the code in a very compact way. It's very important. If you are building complex networks, you can spend hours debugging your setup, your code, and you would not be able to do it unless you have nice abstractions and blocked organizational capabilities within your code base. Hopefully, by the end of this talk, you'll get a sense of that. Interesting. So Uber recently uses the Microsoft Cognitive Services, which is powered by, again, the Cognitive Toolkit, for driver face recognition. And it is aiming to improve the customer satisfaction or their experience with regards to their personal safety. How many of you have played around with that how-old.net? It's been a while. OK, if you haven't, I would seriously encourage you to try it out.